Hi, good morning. Welcome to TechFlix Info, the engineering tutorial hub. Today, we'll be going through the Large Hadron Collider, which will unveil the origin of Earth or the universe, how the life has been created and has been evolved with the help of this particular animation or the Large Hadron Collider. So it all started with this compressed hydrogen over here. So hydrogen is in compressed stage initially in a Large Hadron Collider system, and the hydrogen atoms are passed in a controlled rate like this to a chamber over here. So this is a chamber. The red colored particles, as you can see over here, are the hydrogen atoms which has been passed to this particular chamber, where the electrons are removed and the protons, which have positively charged, are moved towards the next stage. So here the electrons have been removed, and these are the protons, as you can see over here, which are positively charged, and they actually pass through this system, which accelerates the speed of these protons, and this actually accelerates its and attains a speed of 1 by 3 or 1/3 of the speed of light, and where it enters the stage 2. So this is a stage 2 of the system, which it enters another path, which actually contains about four rings. Here you can see three, but actually there are four rings where these protons will actually come and enter this four rings. It's a booster. The protons enters here actually circulates, and its speed actually increases to about 91.6 percentage the speed of light, and they are accelerated with the help of a magnetical field. An external magnetical field has been applied towards this ring over here, and also a magnet has been placed on the other side, so it actually accelerates the speed of these uh, protons inside. So actually what happens that they attain a speed of 91.6 percentage, and then it moves towards the next stage, which is called as the proton synchrotron. So this is how it enters the proton synchrotron. It has a circumference of about 628 meters, and here it travels for about 1.2 seconds, where the speed of this protons increases to about 99.9 percentage the velocity of light. So here it attains the speed of 99.9 percentage the velocity of light, and here the transition happens, and then it moves towards the next level. So what happens is that here the energy which has been attained by this particular protons cannot increase further, because it is reaching its limiting speed. That means the limiting speed of light. So what happens is that instead of increasing the energy, its velocity actually will not increase, but to that what happens is that a mass is increased. An increased mass of these protons is happening at this stage, because the increase in energy will not reflect in increase in velocity. Instead it will reflect in increase in mass. So the kinetic energy which is received by this proton is converted, or it can be termed in terms of proton electron volts. So it attains a definite amount of proton electron volts, or we can say it is like 25 giga electron volts, or GeV. That is 25 percentage more than when these protons are at rest. And from here it moves towards the next transition, where it is called a super proton synchrotron. So this red colored circle is the super proton synchrotron. So this shows all the stages. So here this is a compressed hydrogen. So here it is the stage one, it is accelerated primarily to about like one-third speed of light. Then after here, it reaches the proton uh, uh, booster, where it attains a speed of 91.6 percentage speed of light. Then it reaches the proton synchrotron over here, where it has a speed of 99.9 percentage the velocity of light. Now it enters the super proton synchrotron. So this is a super proton synchrotron, which is about 7 kilometers of circumference, and the protons can take it in a speed of 450 Jeff. So that is actually what's happening here. So this is how the protons are circulating inside the super proton synchrotron. So from there it passes towards the last stage, or the final stage. It is the Large Hadron Collider. So through this path, both the sides, it is entering towards the Large Hadron Collider. So this is the Large Hadron Collider. So this is how it enters. You can see it is entering the Large Hadron Collider in two paths. It's spread over 27 kilometers of circumference, and it has two vacuum pipes which cross over. So this is one vacuum pipe and this is another vacuum pipe, and they cross over in the middle. So that's how it's been constructed. So as this proton enters this hadron collider, you can see this red colored is also protons, and this yellow colored is also protons. So they actually enters into this vacuum pipe in opposite direction. That means in the green pipe it moves in the clockwise direction, and in the red pipe it moves in the anti-clockwise direction. So both these protons will cross over through this pipe where it is joined, so it can result in a collision. Here we have kickers which improves or increases the speed of these protons. So what happens is that as the speed increases and they cross over, it results in a collision over here. So this is how they move inside the LHC, or the Large Hadron Collider, and result and when they cross over, it results in a collision, or the debris from this collision is being tracked in by detectors and connected towards the supercomputer, which takes out the data. So actually here these protons are moving nearly in the speed of light. That is about 11,000 times it circulates through this Large Hadron Collider in a single second. So you can understand 11,000 times it moves around in 1 second. That is about 7 tetra electron volts have been created here. That is 70,000 7,000 times, I believe it's 7,000 times heavier than these protons are at rest. So what happens as they move in, this is the crossover path. You can see here the protons cross over here, and here the protons also cross over in opposite direction. So what happens is that as they cross over here, a collision results in a collision. So here this is a collision happening, and it's about double the energy of these protons are released. That is 14 tetra electron volts are released. So this is nearly the scenario happening in Big Bang, and these data, or these molecules or the particles been coming out of this Big Bang have been tracked by the supercomputers which are connected with the detectors, and this data will give us an idea about how the Earth, or the universe, has evolved, and how the life has started here. So this is a briefing about a Large Hadron Collider, or the God particle. So for more details or more engineering or technical related videos, you can visit our blog or our YouTube channel, and our also Facebook page. Okay, and we give the credit of this video to the YouTube upload about the Large Hadron Collider. We have taken some data from the internet and also from the YouTube, and has accumulated this so that we can help other people to learn more about the Large Hadron Collider. Thanks for watching this video.